Factoring and solving polynomial equations, part 2. All right, we're not solving yet. We're going to look at some more factoring. In this video, we're going to be looking at the sum and difference of cubes. All right, there's actually two formulas for this. All right, so here are the two formulas. Here's the sum, and here's the difference. All right. Now you notice here, when I'm given a formula, I like to figure out if there's like a pattern to this, because if there's a pattern to it, then it makes it look a lot easier. Actually makes it a lot easier to factor. All right. So, in order to factor a sum or difference of cubes, both terms must be perfect cubes. Now, what I mean by perfect cube is like saying 2 times 2 times 2 is 8. 8 is a perfect cube. Let's see, 27 is a perfect cube because that is 3 times 3 times 3. So if both of these terms are a number that you can multiply by itself 3 times, then they are perfect cubes. And if they are perfect cubes, it doesn't matter if we are adding or subtracting. It does not matter. As long as the two terms are perfect cubes, in other words, a number multiplied by itself 3 times, then I can factor it into either of these two forms, depending on if I'm given a plus or a minus. Okay. Now you notice here is once I know what the number is that you multiply by 3 times to get this, all right, the sign stays the same, and then here the sign's opposite, and it goes positive. Here, if we're doing difference, it stays the same, but this time it's opposite, but then the last term is positive. So no matter what, will always be opposite of what these are. All right, so we're going to look at 3 examples, and hopefully that should be good enough. All right, example number 1. All right, we got x cubed plus 64. Well, this right here is a perfect cube because that's x times x times x. Now 64, that's a perfect cube because that's 4 times 4 times 4. All right, so since both of these are perfect cubes, then that means I can factor this using one of these formulas. In this case, I'm using the sum because it's addition here. So it says a plus b. Well, in other words, your a will be x and your b will be 4. So therefore, we have x plus 4. All right, a, you square it, so if a is x, it will be x squared. Now I said here the sign's opposite. So if it's a plus here, this would be a minus here. Then up here it says a times b, so that's x times 4, so that's 4x. Then a plus, and the last term you square, b squared. So b is 4, so it'll be 4 squared, which is 16. And there you go. Okay, another example. Okay, 125 times x cubed minus 8. All right, 125, that is 5 times 5 times 5. Here, this is x times x times x. And 8 is 2 times 2 times 2. Since everything is a perfect cube, that means it's factorable. All right, so that means a is both the 5 and the x, so it's 5x. b is 2. So here we go. So you just do 5x, keep the sign the same, which is a minus here, so it'll be a minus here, and b is 2. Formula is you square the first term, so 5x squared is 25x squared. Change the sign, multiply the 2, 5x times 2 is 10x, and then you square the last term. In other words, negative 2 squared is positive 4. And there you go. It's completely factored. And the last example, 27 times x cubed plus 216. So let's see, 27, that is a perfect cube. That's 3 times 3 times 3. Again, this is x times x times x. And 216 is 6. And a little brain fart. Oop, can't say the F word. All right, so A is 3x and B is 6. Okay, so here we go. A and B, the sign stays the same. So that's a plus, that's a plus. Now the rest of the thing is based upon what you have here, if you haven't caught on yet. So you take the first term, you square it. So that's 9x squared. Change the sign. Multiply the two terms. So 3x plus, or excuse me, 3x times 6 is 18x. Square the last term. So that will be 36. And there we go. We have factored using sum and difference of cubes. Now you notice here, in both of these terms, I can still factor out a common monomial. All right, because look here, in both of these terms, I can factor out a 3. In these three terms, I can factor out another 3. All right, we will cover this a little bit later, but I just wanted to show you how to factor sum and difference of cubes.